In this lesson, we are going to learn about a problem from Differential Calculus, Maths and Stats, Book 1, Commerce Stream, Maharashtra Board. It is from exercise 3.3, question number 3.3. Find dy by dx if y is equal to 10 to the power x to the power x, 10 plus 10 to the power x to the power 10 plus 10 to the power 10 to the power x. Now, you have to understand that you cannot apply x to the power n formula here because it is 10 to the power x to the power x. Okay, because there is an exponent which has got a variable. When we talk about x to the power n, then n is a constant. Okay, and that's how when we take a derivative of this, we get n into x to the power n minus 1. Similarly, the middle term, which is 10 to the power x to the power 10, is also not of the same format, and the third one, which is plus 10 to the power 10 to the power x, is also not, the exponent is not of the form of constant. So, take a look at the solution, how we solve it. So, the question is y is equal to 10 to the power x plus x to the power x plus 10 to the power x to the power 10 plus 10 to the power 10 to the power x. So let u be 10 to the power x to the power x, let v be 10 to the power x to the power 10, and let w be 10 to the power 10 to the power x. Okay, so y becomes u plus v plus w. Now differentiating both the sides with respect to x, what we get? We get dy by dx is equal to du by dx plus dv by dx plus dw by dx, and let's give this as a equation number 1. So u is equal to 10 to the power x to the power x. Taking log on both the sides, we get log u is equal to log of 10 to the power x to the power x. And here you pay attention to the exponent here, which is x to the power x. You know the rule that log m to the power n is written as n log m, and we are going to apply the same thing. So log u is equal to x to the power x log 10, and we know that log 10 is a constant. So now still we see that I have an exponent which is a variable. So we need to apply log again. So taking again log on both the sides, what we get is log of u is equal to log of x to the power x log 10. Applying the rule of log m log, and some of the log you need to revise. You please take a look at the other lessons. Log of m into n is equal to log of m plus log of n, and that's what we are going to do. So what we get is the log of u is equal to log of x to the power x plus log of 10. So log of u is equal to x log x, which is again applying the exponent rule here, which is log of m raised to n plus log of 10. Now if we differentiate both the sides with respect to x, what do we get? See, so we have just reproduced the equation. Log of u is equal to log x plus log of 10, and this is equal to d dx of log of u plus is equal to d dx of x log x plus d dx of log of 10. Okay, I mean this should be a bracket. There should be an additional bracket out here, but it's okay. Now you see, we are not much bothered about this particular term because it's a constant term, log of 10. So it's going to be eventually 0. Derivative of a constant is a 0. It's a constant term. But what happens to the left hand side? It becomes 1 by u log 1 by log u into d dx of log u is equal to x into 1 by x plus 1 into log x. We have applied the product rule out here where x is one expression which is u. You may consider it to be u, and log x as v. We're talking of product rule u into v. So it is x into 1 by x plus 1 into log x plus 1 by log 10 into 0, because derivative of log 10 is 0, which is a constant term. So what we get is 1 by log u into 1 by u. Now this log u, d dx of log u is 1 by u into du by dx plus 1 plus log x. Here these two gets cancelled. So what you are left with here is du by dx is equal to u log u. So it is basically this entire thing getting transposed to the other side. You're putting a bracket around 1 plus log x, and that's the expression which we have got it for du by dx. We are going to repeat the same thing for dv by dx and dw by dx also, the steps. So eventually, in place of u, because the u had been considered as u is equal to 10 to the power x to the power x. So let's keep replacing those in our right hand side expression. So instead of u, it is 10 to the power x to the power x. Log u, we had got it as x to the power x, and rest of the terms log of into log 10 times 1 plus log x. Coming next to v is 10 to the power x to the power 10. So taking log on both the sides, what we get is log v is equal to log of x to the power 10. So log v is equal to x to the power 10 log 10. So again here you pay attention, we are treating this entire thing as an exponent. So it is log m raised to n, which is n log m. Now here we don't have a challenge. Differentiating both the sides with respect to x, log 10 is anyway constant, we can take it out. X to the power 10 is of the form of a to the power x. Let's take a look at it. So log v d dx of log v is equal to d dx of x to the power 10 log 10. Log 10 is taken out common, which is out here. And x to the power 10 is of the form of x to the power n, where n is a constant. So when you differentiate, the result is n(x to the power n minus 1, which is 10(x to the power 9. So transposing v to the other side, which is going to be 10 to the power x to the power 10. We have replaced this v and transposed it onto the other side. It is 10 to the power x to the power 10 into 10 to the power x to the power 9 into log 10. So that's your final expression for dv by dx. Now coming to dw by dx, w has been given to us as 10 to the power 10 to the power x. So taking log on both the sides, we get log w is equal to log of 10 to the power 10 to the power x. So log w is equal to 10 to the power x log 10. So again, this has been taken as the exponent. And we know, differentiating both the sides with respect to x, we get log w d dx of log w is equal to d dx of 10 to the power x log 10, which is equal to 1 by w into dw by dx, and 10 to the power log 10 taken as common, and 10 to the power x can be, is when you differentiate, you get it as 10 to the power x log 10. And how do we get it? That's the formula. We know d dx of a to the power x is a to the power x log a, and applying the same rule, we have got the solution out here. So dw by dx is equal to w times 10 to the power x. You see, this log 10 and log 10 can be combined, and it becomes log 10 whole square. Now let's replace the w. So dw by dx is equal to 10 to the power 10 to the power x into 10 to the power x into log 10 whole square. Rearranging and just writing it neatly. Now we have got du by dx, dv by dx, and dw by dx. So you substitute it in our main solution, which is equation number 1. So dy by dx becomes 10 to the power x to the power x into x to the power x into log 10 times log 1 plus log x plus 10 to the power x to the power 10 into 10 to the power 10x to the power 9 into log 10, 10 to the power 10 to the power x into 10 to the power x into log 10 square. Now that's the answer. You see, the error which most of the students are doing in this is, while taking log, if you don't apply the exponent rule appropriately and the log rules appropriately, you might lose the track of getting the solution. Do rewind and check if you get any doubts, and you can write your messages if you wish to have further clarification on the question.